All right, so in this video, I'm going to talk about what lessons we should be learning from all the optimization problems we've done in the previous video. Why shooting another video for this? Because I think those lessons are very important, and most of the time students get lost in those lessons and sort of understanding of those lessons. To me, I think the numerical solution for the monopoly optimization problem is pretty straightforward. You already given the cost function, you already given in the question, you already given the demand curve, and so all you have to do, find the revenue, price times quantity, take its derivative and find the marginal revenue, and calculate marginal cost, set them equal, and solve for optimal quantity. And once you find the optimal quantity, plug that back into the demand curve to find the optimal price. That's it. So it's, I think, a very simple numerical exercise. However, the general lessons that we should be learning from the monopolies optimization problem are sometimes more valuable because the instructors try to test you if your understanding of those lessons are good enough. So what are the lessons? But before that, let me just recap what we learned in the previous video. If you remember, we learned the marginal revenue of the monopolist has to be equal to marginal cost of the monopolist because the monopolist is a profit maximizer. Same is true for perfectly competitive market in the sense that the marginal revenue of the competitive firm must be equal to the marginal cost of the competitive firm. I didn't put C or M here because the cost is the same whether it's monopolist or competitive, so the marginal costs functions will be the same. However, the marginal revenue of the monopolist is slightly more complicated, so it's price plus this term, which is output multiplied by the derivative of the price. So here the P is the inverse demand curve, so it's a function of Y, but I just ignored the parentheses Y for notational simplicity. Well, on the other hand, for a perfectly competitive market, the revenue is P times Y, and P is given. It's the market price, and it's determined by the market price and market supply. So therefore, when we take the derivative of the revenue, we just take the derivative of Y. So therefore, the marginal revenue is equal to price for the perfectly competitive firm. All right? So what are the lessons? I think there are three important lessons that you should remember. The first one is why the marginal revenue has to be equal to marginal cost. Well, whether you're a monopolist, whether the firm is monopolist or perfectly competitive or oligopolist, doesn't matter. Every firm that tries to maximize profit will actually choose its quantity where its marginal revenue is equal to its marginal cost. All right? Well, we derive it from the mathematically from profit maximization problem, but intuitively, what does it mean? So here's the intuition. So when I say the lesson, I mean the intuitive explanation of that equality. So the marginal revenue is the additional revenue you raise by selling an additional product. And the marginal cost is the additional cost you have to suffer by selling an additional or by producing an additional output. So imagine you are thinking of selling, say, 99 products, okay? And you're thinking of producing the 100th product. So should I produce and sell 100 product or 99 product? So how do you make that decision? Well, what you should be looking at, it says, you should be looking at what is going to be the revenue of this, the additional money you're going to get by selling this 100th unit versus what is the money you have to pay by producing of this 100th unit. Okay, so that's it. So if the marginal revenue of the 100 unit is above than the marginal cost, well, that means you are actually making additional money out of selling this 100 unit. So you should sell it. If the marginal revenue is lower than the marginal cost of the 100th unit, well, it means you're actually making loss by selling the 100th unit. So you should actually not sell it. You should sell less. All right. By selling less, you will probably decrease your cost because the cost will probably increase. All right. So therefore, you should not sell the 100 units. When they're equal, it means, the selling and not selling, it balances out. So that's the point you should stop. Well, why the equality matters? Well, it's kind of the niceness of the profit function. So if the if the profit function is some continuous function, and especially if it is concave, well, it means, remember, this is the point where marginal revenue equals marginal cost, all right? Whether you're a monopolist or not. So it means your marginal revenue for all those quantity levels are actually above the marginal cost, all right? So it's profitable to sell additional units. So keep selling, all right? Sell more and more and more. At some point, it's gonna balance out. Once you exceed this, all right, you are already making profit. So you're not making loss, but the additional unit that you're selling, you are making loss, all right? So you're making loss means, you already make some profit by thinking of selling 99 product, but by selling the 100th product, now you are actually subtracting away from your product of 99 goods that you're selling. So you shouldn't be producing this 100th product. You should stop exactly at that point. Right? So that's the idea of why the profit maximization implies marginal revenue equals marginal cost. Obviously, if we had a discrete scenario, we don't have a continuous demand curve, but we have 5 customers, for example, or the cost functions or the profit function isn't continuous. Obviously, marginal revenue may not be equal to marginal cost. So this is the niceness of the continuity of the demand curve, the cost function, and everything. All right. The second lesson that we should learn is why the marginal revenue of the monopolist is lower than the marginal revenue of the competitive firm. Well, the marginal revenue of the competitive firm is just equals to the price, which is determined by the market supply and market demand. So P is the inverse demand curve. And the marginal revenue of the monopolist is that price, the same price, plus some term, but this term is negative because the derivative of the demand curve is negative. It's a downward sloping demand curve. So therefore, the marginal revenue of the monopolist is going to be equal to something less than the marginal revenue of a competitive firm. Well, why is that? The intuition is simple. If you're in a competitive market, you take the price given. All right, so let's say this is the product I'm selling, a marker, and for each marker I sell, the price is, say, $1. Whether I sell 1 unit, 10 units, or 100 units, as long as there's demand for those, I'm going to get exactly $1 per marker. So the marginal revenue of each marker is just $1. All right. However, if I'm monopolist, selling $1 versus, selling 1 marker versus 10 markers versus 100 markers differs in terms of prices, because for 1 marker, I can charge very high price because all I need is just 1 customer. All right, so I'm basically aiming the highest paying customer. If I sell 10 products, well, I can decrease the price, but I don't have to make it $1. All right, so say, for example, $5, because all I need 10 highest paying customers. I don't really care about the rest. But if I sell 100 units, well, the price is going to be much, 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 much less. All right, so think it this way. So if I sell already 99 products and 99 markers, let's say the price is, $1.20, okay? So this is how much money, so $1.20 per marker. However, if I want to sell 100 units instead, so I just increase the number of sales by 1 unit, okay? Normally, because it's a downward sloping demand curve, well, it's got to be something lower than this. Okay, so let's say, again, this is $1. Right? This is just a numerical example to make my point. Okay, so what happens is that from this one additional marker, I am actually, so here I'm going to be making 99 times $1.20. I don't know what that equals to. That's my revenue, right? So here I'm going to be making 100 times 100. Okay? So what happens is that for give me a moment. Okay, so I just wanted to make sure this number is correct. So if I sell 99 units, I'm going to be able to sell all of them at a price $1.20. And then the revenue I'm going to be raising is, forget about the cost for now, I'm looking for the revenue, the marginal revenue, right? $100, $118.80. However, if I want to sell 100 units, well, this time I have to charge $1 for each. Well, in this case, the revenue is going to be 100 times $100. So the revenue is declining. That means the marginal revenue is negative. All right. So here, what this explains is that the marginal revenue of the monopolist here is negative, is clearly less than the price, P. Well, what is P? So P is the price you're going to get by selling one more item, right? So this one additional marker is actually bringing you $1, all right? However, what happens is that you give up 20 cents for each 99 units that you were planning of selling, all right? So this is exactly why this $18.80 gap is occurring. You decline the price. So this is, by the way, because of the uniform pricing. You can't say, oh, I'm going to sell all the 99 units at $1.20, and then the 100 unit is going to be $1, so I make a discount. No, this is the assumption of uniform pricing, and it's so important. You have to charge the same price for all the products. So when I sell 100 products, the price is $1 for each 100 of those products. All right? So what happens is that I give up this 20 cents that I was actually receiving if I were to sell 99 products. And so, on the one hand, I gain $1 by selling one more marker, but on the other hand, I give up 20 cents for all the 99 units. So, if you make the standard, sort of an accounting calculation, the marginal revenue, therefore, is going to be lower. The marginal revenue, meaning the additional revenue you're making with this additional unit, which is negative in this numerical example, is clearly less than the $1, which is the price of this additional unit. And so it is true for this numerical example, but it's true in general. It's like whatever the price is, whatever the quantity is, because you have to charge uniform pricing, for every additional unit, you're raising P dollars, all right? But don't forget, if you don't sell this additional unit, the price would have been higher, and for all the other products, before that product, you would have making this extra money. And so this extra money will always overweight, this extra money is gonna overweight this $1, and so the net marginal revenue is going to be lower than the price of that additional unit. Okay, I hope that was clearer. So the third lesson that we should learn is, what about the optimal price and quantity for the monopolist in comparison to the competitive firm? This is particularly important because in the next video, I'm going to calculate the dead weight loss. And so we usually need that graph. All right. So let me first tell you the conclusion. Well, the price of the monopolist is almost always, always greater than or equal to, in some instances, depending on the cost function, depending on the demand function, the prices might be the same, but it will never be lower than the competitive equilibrium price. All right, so the monopoly will always be charging higher or the same price, and the quantity of the monopolist will always be lower than, or maybe sometimes equal, the output of the competitive firm. All right, so that's the conclusion. Well, how do we know that? And here's the explanation how we know that. So let's say this is output, this is price, and everything related to money, like cost, the profit, etc. So my inverse demand curve is going to look something like this. So suppose it is linear, all right? So it makes life easier. So suppose it's linear. All right. We know that the price of this graph will be very important in our future topics as well. So try to understand every line and curve in this graph. So the price is equal to marginal revenue of the competitive firm, right? If you remember. What about the marginal revenue of the competitive firm, monopolist? Well, it is definitely lower than the price. All right, so it's underneath this curve. All right, is it linear? Well, that depends. That depends on the assumption. But if the demand curve is linear, well then this term, the del P, del Y, it's going to be a constant, a negative constant, like -2, which is the slope. And so it's -2 times Y, all right, plus the linear function, meaning this is going to be a linear function, all right? First. Second, it's going to lie below the demand curve. And then the third, so it's going to be something like this, the marginal revenue of the monopolist. And the third, these two curves are going to, kiss each other on the y-axis. Well, why is that so? Well, when y is 0, okay, when y is 0, this term is 0. So the marginal revenue of the monopolist is P, which is equal to the inverse demand function. All right, so they're exactly the same thing when y is 0. So this is the marginal revenue of the monopolist. Good. What else? Well, we have the cost function. It can be linear, could be non-linear, I don't know. I'm just going to randomly draw something like this. So this is the marginal cost. Think of this as like cost equals y squared. Well, then it becomes linear, I'm sorry. Anything else, okay? X cube, for example. All right, so the marginal cost curve is going to look something like this. Good. Remember, so first of all, what is the perfectly competitive equilibrium price and output in this graph? Well, let me get the blue pen. So perfectly competitive market, price, and marginal revenue and marginal cost satisfy this. So price equals marginal cost. This is supply and demand. So remember our arguments in Intermediate Microeconomics 1. The marginal cost curve is the supply curve of a competitive firm. So P is the demand, MC is the supply. So whenever P and MC intersect, that's the point of equilibrium output and price. So marginal cost and the demand curve intersect at that point. So you know what? This is the competitive equilibrium output. So I call it YC. And this is the competitive equilibrium price. I denote it as PC. Well, what about the monopoly? The monopoly chooses its output where marginal revenue equals the marginal cost. So this is its marginal cost curve. Both competitive and the monopolist use the same marginal cost curve. And the marginal revenue curve, so they're equal to each other, means they're intersecting with each other. So therefore, this is the monopolist output. And what about the price? This isn't the price, okay? So if this is the output, the monopolist can charge very high price. Well, very high price. So this is the monopolist price, all right? So as you see, the monopolist price is higher than the competitive firm's price, and the monopolist output is lower than the competitive equilibrium output. So here, this difference we call price markup. All right, so almost always the monopolist is going to charge higher price. So higher than the marginal cost price. The PC is the marginal cost pricing. This is how we call it. And this is the price markup. All right, so in the next video, I'm going to start with this graph and show you, talk about the consumer surplus, producer surplus, and deadweight loss. But I want to make one very last moment and important point is that here I am comparing monopoly with perfectly competitive market, but I don't know. Something may be off for you is like there are many sellers in this perfectly competitive market. So how come this is the marginal cost curve of one firm, right? So therefore, this is the supply curve of one firm. What about the other suppliers, the sellers? So the market supply, aggregate supply should be larger than this. No? Good question. So here we are actually cheating. So I just wanted to make that explicit out there. It's like clear, hopefully. So when I compare monopoly with perfectly competitive market, we assume the following. Remember, there's a demand curve, okay. Nothing special about that. There's a cost curve of one firm. And there's a cost curve of, okay. So this is not the cost curve of one firm. So you can think it this way. The PC means perfectly competitive market. You can think of this, the aggregate cost function. All right. So all the firms in the market have exactly the same cost function. So if there are n many firms, C divided by n is the cost function for each individual firm. And so I aggregate it. So this is the aggregate cost function, and hence this is the aggregate supply function. Or we cheat it in another way. We say, oh, actually there are many sellers, but we can just use as if there is one seller with this cost function. And that one seller actually represents the entire market. But one caveat, obviously, is that one seller, it's not literally one seller. It's just a representing agent, all right? So that seller cannot determine the price. It takes the price as given. We actually use that interpretation a lot in sort of macroeconomics. So there's for example, representative agent, representative customer. All right, so rather than talking about the demand and all the other customers, just one customer, it represents the market. But it's not like monopolist. The seller is not monopolist. It takes the price as given. All right. My interpretation is like, oh, this is an aggregate cost function. There's no such thing, by the way, but you can think of it as like aggregate cost function, and hence this is the aggregate supply curve. This is the market demand, the aggregate demand anyway. So therefore, the YC is the aggregate output, the total output in the competitive market. And YM is also total output in the monopoly because there's only one firm. And PC is the market price. All right? So that's why this comparison is legit under this sort of transformation. All right. Hope that was clear.